Okay, I'm just gonna make a few adjustments here and get started. I'm gonna start with just a brief slideshow and then we'll get started with some live demonstrations. My name is Shawn Schreckengost. I'm a business development manager for Tristar. And I believe Devin Shearer is joining us virtual as well. He is one of your account managers for the BadgerUG group. Um, I was asked to do a presentation today and about some advanced capabilities in Creo. And one of the things that I like to share and makes a good presentation is how do we model for flexibility in our assemblies. And I've kind of taken, a couple different looks at different types of parts that might be flexible and, come up with ways to model those so that we can use them in our assemblies. Before I do that, though, I'm not only a business development manager for TriStar, I'm also a Creo parametric specialist. I've been using, or I've been with TriStar for 14 years. Prior to that, I was direct for PTC for 16 years. I've got a 44-year background in mechanical engineering with 42 years on various CAD platforms. So I've been doing CAD for a little while anyway. I've been using PTC products for 37 years, with 27 of those years focusing on Creo parametric. And I live in a very small town right in the middle of Colorado. Beautiful place to visit. Kind of harsh to live here, but we love it. This slide I like to share because in my role as a consultant anyway, I've been able to visit many customers, not just on the phone, but live on site. And when I visit a customer live on site, I like to kind of put a pin in my Google Maps so I can remember where I've been. But I visited over 260 customers worldwide, and the reason I bring this up is because a lot of times when I visit customers, I ask them, the users, how long have they been using Creo Parametric? And a lot of times users have been using it 5 or 10 or 15 years even. But then I asked them, so where did you get your 15 years experience? And that, well, right here at this customer, right here at this company where I've been working. Well, there's a difference between using Creo 15 years for one company doing one product versus seeing many different ways that people use Creo. And so that's the reason I bring this up, is because when I visit customers, I'm able to bring this experience that I've gathered from visiting all these other customers and seeing things they do and how they use Creo. And I learn from that. I learn every day from visiting customers. And then I like to bring what I learned into my presentation. And so a lot of things that I'm going to show you today are some things that I've learned maybe from visiting customers. So really the techniques that I want to share with you today are some advanced filing techniques, but really geared more towards flexibility. And what we mean by flexibility in the assembly is not the flexible modeling environment. It's not creating a rubber band, but it's creating a component that you use in the assembly, that in the assembly it may have some variations, changing size and things like that. Springs are really good examples of things that are variable in the context of the assembly. So when we talk about flexibility, we're really talking about variability within the context of the assembly. So when we think about the reasons for doing this, first and foremost is we're really trying to reduce or even eliminate the use of family tables for these types of components. I've seen customers build a dozen different O-rings of the same O-ring as family table instances just so that they can use them in the assembly. Of course, with a family table, you have all that baggage that comes along with a family table, plus using PLM systems, family tables have a lot of overhead. So we have to think about those things, and also the bill of materials, because if we're using a family table instance, that name of that instance is different for each instance that we use. And therefore, our bill of materials doesn't accurately count up the number of those components. So if we can use the same name over and over again, but then just vary it in the context of the assembly, then our bill of materials becomes pretty accurate. A lot of things we have to consider when we're taking this approach. First of all, how will this component be assembled? And then also, what is going to drive the variability of the assembly? So when I take a modeling approach towards this, it's a little bit different than modeling something that you're going to manufacture, and then because of that, you need to document it, and you want to model it in a way that captures all the design intent, so that we're really kind of driving that model centricity. When we're building these types of parts, these are typically library parts, right? So a library part, you might have a spec from the supplier that defines what that part is. So we don't really necessarily need to capture that design intent in the context of the part. What we're really trying to capture is how can we make this part flexible or variable in the context of the assembly. So when we start getting into that, then you really need to know a lot more about Creo and the features that are available to us that enable that flexibility. I'm going to show you some things today, the way we use Creo to make that happen. How we use our sketch geometry. A lot of times people create a solid sketch with solid geometry and they have dimensions and that's all they need. But in these types of parts, again, we're modeling to make these parts flexible. We have to use a combination of solid geometry and construction geometry and the constraints that get us the variability that we need for that particular part, whether it be a spring or a screw clamp or an O-ring or something like that. A lot of times we use parameters and relations to help control the sizes of the parts. And we're going to do that today. But more importantly, and most importantly, is not only do we have to model for the part to be in its static state, how it would be sitting on the shelf, but we also need to be able to model it in its dynamic or varied state. How will it be assembled? So if you think about a typical part that might be flexible or variable, a tension spring is a very good example, right? We have thousands and thousands of different variations of tension springs. And then when, of course, we assemble these tension springs, they're going to be under tension in the assembly, so they may expand a little bit. But when they do that, their mass properties don't change. Things like that need to be consistent, even if we use the same spring over and over again in different locations in our assembly. So things that we have to consider when we're modeling these springs is how does the spring look in a static state, but also how is the spring assembled, right? How is it varied when we put it in the assembly? And the ways that we assemble these tension springs are as varied as the springs themselves, right? There's thousands and thousands of different applications for creating a tension spring. So I have some other examples that we're going to show very briefly, but I want to focus on the tension spring today. And then if we look at the different types of end styles and different springs that we have, these are your typical dimensions for creating a tension spring. And what we're going to do today is we're going to use this E10 version, which is a long rounded end hook over center, if you will. And then these are the dimensions for the spring in its kind of static state or the way it sits on the shelf. Now, we can't necessarily capture all of these dimensions because we're going to build this in a way that we can assemble it, right? So we're going to use these dimensions as a guide, but we're going to kind of do some things that allow us to vary this spring in the context of the assembly. So with that, let me start my demonstration inside of Creo. What I'm going to do here is I'm going to build a spring that is basically going to kind of hook into this hole here, as well as hook into this hole here on that lever, if you will. So we certainly need, in this case, to vary the length of the spring, right? So if we go back to that, diagram here, we're going to have to vary this kind of 6-inch length here. So that's the distance between the holes, if you will. But we also have some other things that we need to consider when we assemble this spring. And those things are the diameter of the holes that the spring go into. We need to know and model that diameter into our variable component, because that hole size might change, and that's going to affect how that spring gets assembled. So that's something we have to capture. We also have to capture that same hole on the other side of the spring, because the two holes might be different, right? And we want that spring to be assembled correctly. We also need to capture the thickness of the parts that that spring is going to be mounted to. So we have that on both ends. So we really have more than just the length of the spring that's going to be variable here. We have the length of the spring, we have the diameter of the hole on each end, and we have the thickness of the material on each end. So we really have 5 dimensions that we need to vary in this part. So let's go ahead and talk about how we're going to capture that. A lot of it's going to be done within the very first sketch that we create in this model. And then we're going to use that sketch to kind of build the rest of the model. Now, I'm going to go back to this diagram here. When I see users model these kinds of parts, they take an approach that really hinders making the part itself, in that they try to create a spring as a helical sweep. It's really not a helical sweep. A helical sweep only gives us that spring body, but it doesn't give us the hook ends in this case. Now, if I was making a compression spring, then a helical sweep works pretty good for me. But for a tension spring that has hooks on the ends, that helical sweep is not going to work for me. So what I need to do is actually build this part focusing on the trajectory for the spring itself, for the sweep, and not so much as the individual body and hooks of the spring. So we're going to focus on really building this trajectory for this part. So I'm going to create a brand new part. It's going to be my spring. I'll give it a name that kind of represents what that's going to look like, or what that library part might be called. So I'm kind of giving a tension spring with the type of hook end, and then the size of the spring, and then EX for just an example. I can use that in my naming convention. So the first thing I'm going to do is I'm going to lay out those hook ends, which really is going to define the entire shape of the spring, or the size of the spring, if you will. So I'm going to use my front datum plane to sketch on, and I'm going to just create this very simple sketch, but it's going to capture a lot of information for us. First of all, it is going to be symmetric, so I'm going to put a center line right there. So that's a construction center line. When I assemble the spring, I'm going to need a datum center line, or datum axis, to put it through the hole. So I'm going to go ahead and create that right now. So I'm going to put one there, and I'm going to put one right there. And then I also need a datum point, which is going to help me to assemble this spring and to kind of size things. So I'm going to put a datum point there and a datum point in here. So I've got a construction center line, I've got a datum center line, which becomes an axis, and then a datum point, of course, which becomes a point after the sketch. And then I'm going to just create this dimension right here. And I'm going to say that that's 7 for now. And that's just temporary. And then we're going to add symmetry to make these 2 points symmetric around our reference. Okay. Now what I'm going to do is I'm going to use construction geometry to build the profile of the hole. All right, so to do that, I'm going to zoom in here. I'm going to use construction geometry, and I'm going to create a rectangle. And I'm going to let it snap to being symmetric around both this horizontal datum center line as well as my vertical construction center line. And then I'm just going to dial this in. Now, this is going to be a variable dimension in the context of the assembly. So I really don't care too much about the actual dimensions. I'm just trying to get a dimension scheme that I can vary in the context of the assembly. And then I'm going to do the same thing on the other end. I'm going to create that rectangle, and I'm going to give it the same size. Now, I don't want to use equal lengths or equal dimension for these because these holes might very well be different on each end of the spring. So I've got to be able to vary them independently. Now what I'm going to do is I'm going to create a circle that represents my wire diameter, right? So what is the diameter of this spring? So we're going to put one right there. Again, I'm not too concerned about the size of it for now, because we're going to change that later, but I am going to put another one right here. So I need to represent, I will make that equal. We need to represent that in this model so that we can help position the spring as it goes through the hole. Now, a lot of this is going to make sense once we put this in the assembly. You're going to see how things really are going to kind of come together here. I'm going to use a construction point at that location there where that arc becomes crosses that center line, and I'm going to do another one here because we're going to use that as part of our dimension scheme. And then what I'm going to do is I'm going to now start to model the hooks. So what's going to happen here is this hook is going to, in our spring, is going to kind of pass through the center of this kind of wire diameter here, right? So it's also going to kind of have the hook end on it, and then it's going to have another straight piece. So to do this, I'm going to change my construction mode, and I'm going to create an arc by using its center and ends. And I'm just going to sketch it down here temporarily, just kind of get it kind of where I want it, and then I'll put it where I want it in just a moment. But this arc is going to represent the hook, so I'm going to make that horizontal there. We'll make those horizontal, and then I'm going to give this an angle dimension. So to create an angle dimension on an arc, I'm going to select the arc. I'm going to select its vertices, and then I'm going to place the dimension. And that gives me an arc length dimension, which I can then toggle to be an angle. And then that angle is going to be 195. And then I'm going to put that arc coincident with the center of the wire. All right, so we're going to make that arc in that circle be concentric. And then I'm just going to kind of drag that up a little bit just to kind of get it out of my way for a moment. And then what I'm going to do is I'm going to create a construction arc from the center of that arc, and I'm going to put it through those vertices. And then I'm going to make coincident that point with that arc. So what that does for me is as that hook goes through the hole in the assembly, it's really going to touch on the corners of that hole. As that hole changes size, I want the location of this hook to change accordingly. So that becomes pretty important to capture that in our geometry. Then what I'm gonna do is I'm just gonna create a vertical line right here. Whoops, not construction mode. And then that's going to represent my hook length. So I'm going to give it that diameter on that dimension right now. We'll do that. Let's do that one more time. Get the point, get the vertice, place it there. And I'm going to make that be 0.875. That is a dimension that I need from my drawing or from my spec. So I've got that captured. Then what I'll do is I'm going to create this on the other side, right? So we're just going to create that very same geometry, kind of doing the same thing that we just did, trying to capture as much of that as we can. We're going to create an arc with its center and ends. Now again, I'm just going to kind of put this out here and then I'll position it later. This is going to be horizontal to that location there. Come on, let's get it. One more time. There we go. And then I'm going to have that arc length dimension on here. But again, that's going to be changed to be a angle dimension. And we're going to make that be 195. We'll add this vertical line in here again. And then these are all going to be equal. So that line is going to be equal to this line. This arc is going to be equal to the other arc. One arc, come on. Sorry, I'm clicking a little too fast. I know we're limited on time here. So, all right, so that's equal there. Looks like everything's equal the way I want to have it set up. And then I'm going to add a diameter dimension to that right there, because that's my wire diameter. And I think that's going to be 0.0625. And what we'll do is we're going to write a parameter that controls that. All right, so just dialing in my dimensions here. Make sure I got everything the way I want it. Everything looks good here. I've got one more arc that I'm going to create right here. And then we'll make that coincidence so that that point and that rides together. So everything's looking pretty good the way I want this set up. I'm just going to change a couple of dimensions here just to see what happens. That, I'm not coincident here. So every time you see an extra dimension, you want to check, make sure that things are behaving the way they should be. I'm going to do that one there. And I'm going to check this one as well. That diameter looks good. I'm going to just drag this a little bit, see what happens. Okay. So that's the geometry that I need. Now what I want to do is I want to capture kind of my dimension scheme for my static state. So I know I'm going to have the dimension, which is going to be a reference dimension between that location there, which is my point, and this point down here. And then that's my reference dimension. And so then I'm going to make this dimension, force that to be 6. So I'm going to take that and just say minus 0.785, right? So now I've got my 6-inch spring, right? Again, from my spec, that gets that dimension there. I've captured that dimension. And then now let's create a parameter that drives the body diameter and the wire length. So I'm going to go ahead and get out of the sketch real quick. We'll accept that. I'm going to go to my tools. I'm going to create those two parameters. One is going to be wire diameter. And next one's going to be the body diameter. The wire diameter is 0.0625. Should type it in correctly. And then we're going to add another one, which is the body diameter. And that one is going to be 0.75. Okay. So we're capturing these two dimensions. Again, the wire diameter and the body diameter with parameters, because they're going to help us to drive a few things here. I'm going to go back into the sketch now after I create those. We go back into the sketch and we're just going to write a couple of relations to control this. First of all, let's get the wire diameter. So I'll go to tools and relations, and I want SD28 to equal my wire diameter. And then I want the diameter of this to be equal to the body diameter minus my wire diameter. So we do need a diameter dimension for this. Put that in right now. And I think we want to get rid of this 2 dimension down here. So we'll do that. We don't need that anymore. And then I'm just going to write the relation that says that is equal to the body diameter minus the wire diameter. Okay, we're going to verify that, make sure Creo can solve that, and then we're going to say, okay, so that really, again, represents the size of my spring, right? I've got the hooks on each end. I've got some geometry that I'm using to force the location of the spring as it goes through the hole. So I'm just going to modify those real quick and make sure everything looks good here. And then this one, I want that to equal 6. So we're going to add a little bit to this dimension here. I think we want that to be 0.237. And then that makes that 6. And then just one more reference dimension, just in case we need it. I'm going to put one between those locations there. Right? And that's just for reference purposes. Not that we need those dimensions, but it's kind of nice to have that. So again, all of those dimensions then are going to drive my spring. I really don't need any other dimensions to drive this because everything is already defined. What we are going to do is we are going to create a feature called a wrap feature. And that's going to take the place of the helical sweep. The wrap feature needs a surface to land on. So that's what we're going to create right now is that surface. So I'm going to accept this sketch. I'm going to work in my default orientation. I'm going to create on my top datum plane an extrusion. And I'm going to reference the vertice of that hook because that represents my diameter, right? And then I'm going to create a circle that is coincident there. So notice I don't have any dimensions, again, because I've already defined it in my original sketch. But what I am going to do though is I'm going to create a reference diameter dimension because I'm going to need that for controlling my spring itself. So I do need to know that diameter in this time of the model. Even though I've already defined it, I need to know what that is. So I'm going to go ahead and say okay here. And then this is going to be a surface. And then we're just going to use those references on ends of those curves as the length of this spring, or the length of the body, if you will. Okay, so I don't know how many of you are familiar with the wrap feature, but that's found under the editing drop down, and we have wrap. What this allows me to do is create a sketch that's going to land on this surface and then wrap around until it's done wrapping, right? So what we're really going to do is we're going to create the coils for this spring, and the transitions at the end. That all needs to be captured in this wrap feature so that we can then use the wrap as a sweep trajectory. So what we're going to do here is we're going to create that wrap feature. I'm going to define my sketch on the fly here. We're going to create a datum plane. If I can get to my datum drop down, there it is. That is parallel with right and passes through that vertex right there. Get the vertex, right? And then I think I'm missing a constraint in my sketch, but that's okay. We're gonna cancel this for a moment. I think I need an equal length in my sketch here, so let me do that. For whatever reason, we need to make that diameter equal on both sides. So we're gonna add that equal. This one here is equal to that one. I think a little issue with my spring here, but let's get out of there. Should line up there. Yeah. Just checking a few things. Sorry, guys. I had to get my spring to line up. Sorry about this. We're gonna fix it here. Mhm. Okay, got it. Sorry about that. Had a little constraint issue, had to fix. Okay, let's go back now to this one we don't need. We're gonna create that wrap feature now. Okay, so in the wrap feature, as I said, the wrap feature will take a sketch and wrap it around this surface. But it needs to know where to start wrapping around the surface. And so that's going to require a coordinate system, a sketch coordinate system. I'm going to go ahead and reference some geometry here that we're going to use. I'm going to create that coordinate system right there. And I'm going to make the y-axis be vertical. And then I'm going to create another sketcher point right there. I'm going to change that dimension in a moment, but I'm just leaving it there for now. This kind of helps me define the geometry that I want for this wrap feature. Then what I'm going to do is I'm going to create an arc on the end here. And we'll just do that real quick. And then I'm going to do another one down here. And we'll let that snap to that location there. And then I'm going to create a line between these two arcs. They are going to be equal. And they're going to be tangent. And then their radius is going to be equal to 2 times the wire diameter. So we're going to write that relation right now. So we're going to say SD2 is equal to the wire diameter times 2. And we're going to say, okay. And then I'm going to put one more dimension in here. From that location to that location. Now, that dimension is going to represent how many times this wire is going to wrap around that cylinder. So I need to know that reference dimension. So we're going to say okay for now, and I'm going to say okay. But we're going to go and edit this so that I can get that dimension if it was in that sketch. We're going to go edit the definition of this, edit the sketch. There's that dimension. All right. And we're going to find its symbolic value. So we'll edit that again. And its symbolic value is D14. And so we're going to use that then in the wrap to control how many times that wire wraps around the cylinder. So this dimension here, the 8, is going to be equal to that D14 times pi in parentheses, and then we're going to multiply that times 64.5. So what I'm doing here is I'm telling the length of this sketch to be equal to 64.5 times the diameter of that cylinder. But what you're going to see is this is going to jump way out when I accept that, right? And so then that wraps around that cylinder that many times. Okay, so what the reason we do this is because we cannot capture that transition right there in a helical sweep. So by using this manner, we can capture that as part of our trajectory. And then when we create the sweep, it's just a matter of selecting using our shift key to select all the pieces of the trajectory. And then we're going to sketch just a circle here. And then that circle is going to be equal to the wire diameter. So we're going to write one relation here that says SD3 is equal to the wire diameter. Okay. Oh, that's okay there. We're good here. Sketch is done. Our sweep is done. We don't need to see any of these pieces of geometry. And so we'll just kind of hide our layers and save our status here. And then that becomes the finished product. I do need to add one more thing to this sketch here. And we're going to add just a couple more datum points that are going to help us in the assembly process. So you might be thinking, gee, I just watched a guy model a spring, but really, you know, we learned a couple things here. We learned how to use construction geometry to capture some other dimensions of the spring that we need for assembly purposes. And we also learned how to use the rack feature to create a trajectory for a sweep. And that's really the only way we can capture this transitional geometry in our sweep. There's really no other way to get that to be accurate. We also built this spring in a way that it can expand as needed in the assembly. I'm going to go ahead and assemble this. We'll save it first.
Shawn, this is Deb. There was a chat question asking about Can you hear me?
Yes, go ahead.
I- let's see here. No, of course I don't see it. So Emily was asking, is the cylinder extrusion you originally made a skeleton part?
No, this is all internal to this part. So you can consider that cylinder as kind of a skeleton that helps us guide the wrap feature. But it's really not a skeleton in the true sense of a skeleton model in the context of an assembly. But we do need that surface to create the wrap feature. All right. Other questions? Okay, so let's go ahead and assemble this. I'm gonna turn the visibility of that geometry on, so I am gonna need to see it. I am gonna need to see my datum points. But when we go back to the assembly now, what we're gonna do is we're gonna assemble that tension spring that we have. We're gonna assemble it right in the hole here. So I'm gonna use this axis to line up with this axis here. Right? That's going to be a coincident constraint. Our new constraint then is going to take the other axis and put it through the other hole. That's going to be an oriented constraint. And then the spring is almost fully assembled. We are going to assemble one of these datum points to the side of this component here. So we're going to take that datum point and we're going to put a coincident there. Now the spring is fully assembled. Well, let's take a look at really what's going on here. What we want in this spring is that as the spring goes through the hole, we want to hit that corner right there as well as that corner. And then the same thing on the other side, we want to hit that corner and that corner. And that's why we made that construction geometry that represents the hole. So what I'm going to do now that I have this assembled is we're going to make the component flexible. We can, in the component itself, make it be flexible. What I mean by that is I can come up here to File, Prepare, Model Properties, and I can make this component be flexible right here. But that then is going to require me when I assemble it to kind of answer the questions of flexibility. I'd rather do it after the fact. I'm just kind of showing you that although I can make it be flexible in the assembly, I can also kind of force it to be flexible. What I'll do now is I'm going to say, give me this component. I'm going to make it be flexible. When we make component flexible, it's not just dimensions that we can alter. It's also parameters, features, tolerances, materials, and surface finishes. So don't be thinking flexible is a rubber band, right? It's variability is really what we're looking at. What we're going to do is we're going to vary those 5 dimensions, and they all belong to the sketch that we had created. So I'm going to go ahead and select that sketch so we can see all the dimensions that we want to have variable. We know we're going to make that dimension variable, and then I'm going to use my control key. I'm going to select the dimensions for the holes on both ends, and those will all be variable. Now, how do we vary those, right? So to vary them, I'm going to vary the length by a distance, right? So I'm going to measure the distance between this axis and that axis, right? So that gives me that distance, and so we're going to say, okay, I'm going to take the diameters then of the holes, and I'm going to measure them by a diameter. And we're going to say that diameter for that hole, okay. And then we're going to do the same thing on the other side. We'll take that by a diameter as well, measure that diameter. Then what we'll do is we're gonna take the thicknesses. We'll say that this distance here is going to be by distance, and we're gonna measure from that outside wall to the other outside wall. And then we do that one more time down here. This is by a distance as well. And we're gonna say from that wall to that outside wall. Oops. Okay, so those are all of our variable dimensions for this component. Whoops, did I get the one? Let's go distance here, sorry. On there, make sure I get them all. Okay. That is going to be by distance and surface. There we go. Sorry about that. Okay, so that is going to change then our spring to accommodate the assembly conditions, right? So we'll say, okay, here we're fully constrained. So now that spring is assembled correctly on this end to where it goes through the hole and it touches those corners. And then the same thing on this end as well. So the nice thing about that is we do say that we want to edit the thickness of, say, that lever. All right, notice I want to edit that thickness. And instead of 0.125, I'll make it 0.25. And then when we regenerate, we want that spring to fit accordingly. All right. So I know we're getting down to the end of my time here. Any questions about what I've done with these models? Okay, so it's a different approach towards modeling. You have to be thinking a little bit more about how the part gets assembled than necessarily, what are the dimensions of the part, right? We want to understand how that gets assembled so that we can capture that in our model. If changes in the assembly take place, we want our spring to update accordingly. So if I change the angle of this lever, right, I want my spring to update accordingly. Say I'm going to go 15 degrees here, we'll regenerate, and my spring updates accordingly. If I put that very same spring into this other set of holes, it'd be longer in the assembly, but it would still be the same spring as far as my bill of materials is concerned. All right, and that's what I want. I want accuracy in my bill of materials. I also want accuracy in my assembly. So a lot of parts, we have to think a little bit differently about how they get modeled and then how they're used in the assembly. So with that, I think I'm at the end of my 50 minutes. Am I good, Deb? Hello, can you hear me still?
Yes.
Okay. All right, well, thank you, everybody. Any final questions? Okay, well, I hope you enjoy the
Yes.
remaining.
Sorry.
I'm sorry, go ahead.
Hi. So when you do this flexibility
Mhm.
on the spring itself, do does the space in between each of the coils open up, or does
Absolutely.
it or does it make more length and just reflect like a larger spring?
So that's a very good question because a helical sweep wants to do that. If we change the length of it, the pitch stays the same, so the number of coils change. But I used the wrap feature, which says my number of coils was 64 and a half. So it doesn't matter how far I expand this, it's going to have 64 and a half coil, right? So
Okay.
if I say that if I want to edit that length again, we'll edit that dimension. I'll say it's 30 now. And you'll see that when we regenerate, the distance between is going to change. Also the angle.
Okay, yeah.
So, but we still have 64 coils regardless.
Okay,
Good
great.
question, good question.
Thank
Other
you.
question? Okay, so I think the big takeaway from this for a lot of people is, that we can make these parts and make them flexible so that we don't have to create a family table instance for them, which is a lot of overhead, not for the part itself, but for our PLM system, right? So we really don't want to be doing family tables for these types of situations, right? You're much better off making your part be able to accommodate the conditions in the assembly. Okay, well, thank you, everybody, for inviting me to present here. I hope that you enjoyed the presentation and got a lot out of it. I do teach a series of best practices. And one of those sessions that I do in the best practices is how to create these types of parts, not just a spring, but I also, how do we make a hose clamp be flexible, right? You would think that'd be pretty simple, but this was a little bit more challenging than the spring to create this. But this is a flexible component where if we were to put that in the assembly, of course, its diameters would be based on the hose, and even though it's the same plant, we could make that happen. But I know I'm out of time, so I will let everybody go. And again, thank you for inviting me to present today.
Thanks, Shawn. I've got a barking dog, so I'm gonna mute myself too, but thanks so much and thanks to Tristar.